Automating a digital workflow usually encounters a form of physical friction, the difficulty of translating visual on-screen actions into a text-based prompt. To teach an AI to handle a manual process, you have to write out every click, describing the location of buttons and the navigation of nested menus in exhaustive detail. Without exact coordinates, current computer use agents struggle to stay oriented, often failing simply because they lose their place within a complex user interface. This creates a gap for tasks on platforms that lack native API connectors. If you can't plug the AI directly into the back end, you're left trying to explain the layout of the front end. Attempting to solve spatial problems with blocks of text is a mismatch between the tool and the task. Anthropic's Record a Skill feature, found within the Claude Cowork desktop app, addresses this spatial gap. It shifts the user's role from writing code-like instructions to visually demonstrating a task, like a manager training a new hire by sharing their screen. For example, if you need to copy comments from YouTube Studio, paste them into a spreadsheet, and flag them for video ideas, you no longer have to explain the site's navigation. You simply perform the task while speaking your decision-making process out loud. The software records the clicks and the logic simultaneously. This eliminates the need to document the where and how of a specific app's layout. By capturing the performance of a task, the AI can rely on visual mimicry rather than a set of written directions. During the recording, the system parses the interaction into several distinct and simultaneous data streams. It logs exact cursor coordinates and transcribes your voiceover. It captures interval screenshots, over 70 in 2 minutes, mapping visual state changes. The AI then synthesizes these coordinates, words, and images into a structured markdown file, creating a repeatable logic loop. The system also uses the visual context to infer rules. It knows to only extract data and avoid clicking delete or reply on a comment, even without explicit instructions. The breakthrough here isn't the recording itself, but the translation of raw human spatial behavior into a structured execution file. This adds a new layer to how we build automations, requiring a choice between two paths, the connector or the browser. The connector path is for apps with native integrations, like Slack. APIs handle data instantly in the background, making it the most reliable option. The browser path is for isolated tools. Here, visual recording automates the front-end interface directly. Efficiency now depends on triaging tasks, using APIs for data speed and visual recordings for manual UI navigation. Because the AI requires total visual access to your screen to learn these skills, privacy becomes a primary concern. Passwords, financial data, and private messages must be hidden. If it's on your screen during the recording, the AI sees it. While traditional prompting is still necessary for complex reasoning and data analysis, visual instruction simplifies the most tedious part of automation. We are moving toward a workflow where we no longer have to describe the interface. We can just show the computer how to use it.